Alright, so let's go through checkpoint 16. So we have these amusement park ride. Passengers are rotated in a vertical circle of radius 4 meter at a constant speed, meaning that for this right, it's actually a uniform vertical circular motion. Also, of course, there's some machine to keep the speed of the rotation to be constant. So when you see constant speed, always remember that the centripetal force will also be constant. Oh. Okay, so passenger complete one revolution in about 3.5 seconds. So this actually means the period. Because remember the definition of period is the time taken to complete one revolution. Okay, so what is the range of the magnitude of the force that the ride actually exert on the 70 kg passenger? Okay, so first, if you look at point number 1 and point number 2, the normal contact force at point number 1 right, actually is smaller compared to point number 2. Because the so-called the weight of the passenger will contribute to the centripetal force, whereas for the point number 2 right, the weight is actually opposing the normal contact force, meaning that the normal contact force must be larger than the weight in order to still provide a resultant force towards the center of the circle. Okay, so let's determine our minimum force first, which is at point number 1. Okay, first we need to determine our centripetal force. So centripetal force, right, just use mr omega square. So m is your 70 kg, r is your 4 meter, omega is, you just use 2 pi t, because that's angular speed, right? So 2 pi divided by period, which is 3.5 seconds. So this will give you the omega, and just sub inside. So when you do your calculation, your centripetal force will be roughly 902 Newton. So there will be a centripetal force of 902 Newton. Meaning that at the bottom, right, the centripetal force will also be 902, because they say constant speed. Means that the centripetal force will be constant also. Okay, so after that, right, at point number 1, so since we know that normal contact force plus weight is equal to the centripetal force, so the 902 right here is the centripetal force. So I know that the weight is roughly about 70 kg times 9.81. So the weight is roughly about 686.7. So let me just write down. So this thing, right, is about 686.7. So of course, when you calculate for the normal contact force, right, it's 902 minus 686.7. So this will actually give you 215.3 Newton. So it's rather a small normal contact force. Okay, now we move on to point number 2. So point number 2 is where my normal contact force is upward, my weight is downward, right? Okay, so same thing, my normal contact force, sorry, this one should be point number 2. Okay, my normal contact force is N minus mg, right, equal to 902. So the weight is the same. So weight here is 686.7 Newton. So you just move this to the right hand side, right? So meaning that 902 plus 686.7, so this will actually give you a total normal contact force of about 1589 Newton. So by looking at the option, right, obviously A is the answer. Okay, so of course this is the answer for A. Okay, if let's just say we want to look at point number 3. Point number 3, you can see that this person is at that orientation. So how can I actually determine the force that the so-called the bottom of the so-called the floor of the park ride, right, actually exert on the passenger? Okay, so first we must know that the passenger, there's a normal contact force. This normal contact force will be exactly 902, because it's the normal contact force that provide the centripetal force. So this is just 902 Newton. Okay, what about the other two forces? Okay, the other two forces first will be the force, the weight. So the weight is 686.7 Newton. So this is the weight of the passenger, right? Since the passenger is not sliding downward, meaning that the so-called the floor, right, actually exert a frictional force, and this frictional force will be also equal to 686.7 Newton. Yeah. Okay, so let's just say I want to determine the force that the floor actually exert on the passenger, right? How do I actually do that? Okay, so just remember there are two forces that the floor actually exert on the passenger. So first will be your normal contact force, the second will be your frictional force. Okay, so you can see that they're actually perpendicular to each other, right? Means that you can actually use your Pythagoras theorem, so to get the total resultant force. So this is the resultant force of the floor acting on the passenger. So you simply just use this force right here is actually equal to square root of 902 square plus 687 square. I just round off. Okay, so this will actually give you about, let's see, 902 square plus 687 square. Okay, so the total force that the floor actually exert on the passenger, right, will be roughly 1134 Newton. Yeah, so you can see at point number 3, right, is not the maximum, because the maximum is about 1589, and it's also not the minimum, which is about 216 Newton. So it's about somewhere, middle or what lah. No? Okay, so that is how we actually look at these 3 points.